To evaluate integral over S f bar dot n cap ds, where f bar is equal to zi bar plus xj bar minus 3 y square z k bar, and S is the surface of the cylinder. Cylinder x square plus y square is equal to 16, included in the first octant between z equal to 0 and z equal to 5. Here f bar, evaluate integral over S f bar dot n cap ds, where f bar is a vector point function given that zi bar plus xij bar minus 3 y square z k bar, and S is the surface of the cylinder which is included between z equal to 0 and z is equal to 5 in the first octant. First octant I already explained in the previous problem. What is the first octant, second octant, third octant? In the three-dimensional geometry, we have divided the three-dimensional axis into 8 octants. Octant means 8. We have to divide 8 parts. Therefore, first octant means it consists of only positive x-axis, positive y-axis, and a positive z-axis. In this first octant, our surface is the cylinder included between z equal to 0 and z is equal to 5. Now, first draw the diagram. Now, draw the x-axis, z-axis, and y-axis. X, Y, z-axis. Now, cylinder z equal to 0, z is equal to 5. Now this is the cylinder in the first octant between z is equal to 0 and z is equal to 5. So we are taking the part of the cylinder which is included in the first octant between z is equal to 0 and z is equal to 5. So this is the surface of the cylinder included in the first octant. I can also show in another way. This is x-axis, this is y-axis, this is z-axis. Now this is the cylinder. So positive x-axis, positive y-axis, positive z-axis. Here z is equal to 0, here z is equal to 5. So we are taking this part of cylinder, so which lies in the three-dimensional. So we are taking the cylinder which lies in the first octant between z is equal to 0 and z is equal to 5. So positive x-axis, positive y-axis, positive z-axis. Therefore this is the part of the cylinder we are taking as a surface of the our integration. Let f bar is equal to zi bar plus xj bar 3 y square z k bar. This is the given vector, and let phi of xyz is equal to x square plus y square minus 16 is equal to 0. This is the surface of the cylinder. Say this is equation number 1. Now first find the normal to this surface. Now normal to the surface is del phi, that is equal to I bar dou by dou x of phi plus j bar dou by dou y of phi plus k bar dou by dou z of phi. Therefore del phi equal to I bar dou by dou x of phi. So here x square derivative is 2x and y square derivative is 0, as y and z are constant while differentiating partially with respect to x. Next, plus j bar into partially derivative phi with respect to y, partially differentiate phi with respect to y. Therefore x is constant, y square derivative is 2y, and 16 is also constant 0, plus k bar into dou by dou z of phi. So partial derivative with respect to z means x, y are constants. Therefore x square is a constant, y square is a constant, 16 is a constant. Therefore this is 0. Therefore this is 2x I bar plus 2y j bar. Therefore this is equal to del phi. This can also be written as 2 into xi bar plus yj bar. And now unit normal. Now unit normal is equal to unit normal to the surface n cap, that is formula del phi by modulus of del phi. Therefore, this can be written as del phi 2xi bar plus 2yj bar by modulus of del phi, that is square root of 2x whole square, 4x square, square root of I bar component whole square, that is 4x square, plus component of j bar whole square, that is 4y square. Since 2y, there is no component of k bar, that is 0. Therefore, this is equal to 2 into common factor xi bar plus yj bar by 4 is a common factor, that is square root of 4 is 2 into x square plus y square. Therefore, 2 gets a cancel. 2 gets a xi bar, this can be written as yj bar by square root of x square plus y square. From equation number 1, square root of x square plus 16 x square plus y square is a square root of 16. Since x square plus y square minus 16 equal to 0, that means x square plus y square equal to 16. Therefore, this is equal to xi bar plus yj bar by square root of 16 is 4 here. Since using x square plus y square is equal to 16, we have used the fact. Therefore, this is equal to unit normal vector to the surface. This is a del phi. Now, this is equal to del phi by modulus of del phi. This is a n cap. Therefore, now this is n cap. Now, f bar dot n cap. F bar dot n cap. Now, f bar is equal to zi bar plus xj bar minus 3y square z k bar. Zi bar plus xj bar minus 3y square z k bar dot n cap, that is xi bar plus yj bar by 4. Therefore, since I bar dot I bar 1, j bar dot j bar 1, k bar dot k bar 1, and other dot products being 0, this becomes, since I bar dot I bar 1, this is a 1 by 4 is a constant zx, and j bar dot j bar 1, this is x into y. There is no k bar here, so k bar dot I bar, k bar dot j bar being 0. Therefore, this is f bar dot n cap. Therefore, now consider the projection of S in the xy or yz or zx plane, which is suitable. Consider the projection of S in the zx plane. Therefore, ds is equal to, then ds is equal to dz dx by modulus of n cap unit normal and dot product with the unit vector along the axis perpendicular to zx plane, that is which plane, which axis, y axis. In the along y axis, the unit vector is j cap. Therefore, n cap dot j cap. So, if you consider the projection of S in the xy plane, then what will happen? See, if you consider projection of S in the xy plane, then we get dx dy by modulus of n cap dot k cap. The vector, unit vector along the axis perpendicular to xy plane is z. The vector is, unit vector is k cap. Therefore, n cap dot k cap, then n cap dot k cap, this is n cap dot k cap. So the dot product becomes a 0 as it does not contains a k bar. So therefore dot product with k bar becomes a 0. Then denominator becomes a 0. If the denominator becomes 0, then ds tends to infinity. ds means elementary surface area, so that tends to infinity means that is a meaningless. So elementary area tends to 0. So we have to find the limit as modulus of delta sk tends to 0. But here if you can consider in the xy plane, projection of S in the xy plane, we get denominator 0, then ds becomes tends to infinity, that is a contradiction. Therefore ds can never be infinity. So infinity means that value diverges. So we always need a finite value. So that's why we are considering the projection of S in the zx plane, or you can consider in the yz plus yz plane also acceptable, but xy plane does not acceptable, does not permitted to consider the projection of S in the xy plane, as the denominator becomes 0. So you have to take projection of S either in the zx plane or yz plane. So you keep this point in your mind. Therefore, I already explained in the previous problem also, we have to select the projection of S either in xy or yz or zx, depends upon the geometrical situation given in the problem. So therefore we are considering the projection of S in the zx plane. Therefore ds is equal to dz into dx by modulus of n cap dot j cap. Therefore n cap dot j cap, that is equal to xi bar plus yj bar plus in dot j bar, that is y by 4, that becomes y by 4. N cap dot j cap is equal to xi bar plus yj bar by 4 dot j cap, that is equal to y by 4, that is equal to y by 4. This is the modulus of n cap dot j cap. Therefore ds is equal to dz dx by modulus of n cap dot j cap, that is y by 4. This is ds. Now to find the limits of z and x, to find the limits, x and z. Now in the zx plane, y is equal to 0. Therefore equation 1 becomes, what is equation 1? X square plus y square equal to 16. Here y equal to 0. Therefore x square equal to 16. X square minus 16 equal to 0. That means x square equal to 16. X square is equal to 16. Therefore, x is equal to plus or minus square root of 16. That is equal to plus or minus 4. But our surface lies in the first octant. In the first octant, so x always the lower limit is 0. The lower limit of y is always 0. Lower limit of z is always 0. As a positive x-axis, positive y-axis, positive z-axis are only in the first octant. Therefore, x varies from x is equal to lower limit 0 to x is equal to 4. If you can consider the entire xyz plane, then in that case x varies from minus 4 to plus 4. But here our region, our surface lies in the first octant. First octant means x positive, y positive, z positive axis respectively. Therefore, lower limit is always 0 in the first octant. And given that our cylinder lies in the first octant between z equal to 0 and z is equal to 5. Therefore, z varies from z equal to 0 to z equal to 5. Z equal to 0 and z is equal to 5. Now, integral over s f bar dot n cap ds is equal to, since we considered its projection in the xy plane, therefore it becomes a double integration f bar dot n cap. Now here f bar dot n cap 1 by 4 into 3x zx plus xy, 1 by 4 into zx plus xy into ds, that is equal to dz into dx by y by 4. dz into dx by y by 4. Therefore, 4 gets cancelled. Therefore, now x varies from here 0 to 4. Z varies from 0 to 5. Therefore, this can be written as z equal to 0 to 5, x equal to 0 to 4. Now, here this can be written as, here x is a common factor, so zx plus x into y. So here you can see zx by y into xy by y into dz into dx. So separating y for each term in integrand, this is called integrand. Y gets a cancel. And also one more thing, we are integrating with respect to z and x. So variables or functions in the integrand must be either in z or in x, but not in terms of y. So therefore we can transfer this y in terms of x and z. So see equation number 1. X square plus y square minus 16 is equal to 0. Therefore, from this y square is equal to, now 16 minus x square. Therefore, y is equal to root of 16 minus x square. This is equal to integral z equal to 0 to 5, x equal to 0 to 4, z into x by square root of 16 minus x square plus x into dz dx. Therefore, now this is equal to, since here x square plus y square equal to 16, y square is equal to 16 minus x square, y is equal to root of 16 minus x square. This is the fact we used in the denominator of the integrand. Therefore, this is equal to, now here integrate with respect to first either with z or either with x, as the limits of x and z are constants. Therefore, we can integrate with respect to any variable first and any variable after the first variable. Therefore, here now first we are integrating with respect to z. Now, therefore, first integrating with respect to z, so x equal to 0 to 4 and z equal to 0 to 5, keeping other variables are constants. Keeping other variables are constants. Therefore, integral x equal to 0 to 4. Now, x is a constant by 16 minus x square. The entire quantity is a constant. Therefore, z integration z square by 2 limits 0 to 5 plus x is a constant. Integration of 1, that is z, limits 0 to 5 into dx. Therefore, this is equal to integral x equal to 0 to 4 x by square root of 16 minus x square, upper limit 5 square 25 by 2, lower limit is 0, plus x into 5 minus 0 into dx. Therefore, now this can be written as C 25 by 2 into 25 by 2 into, this can be written as x into 16 minus x square. We are writing in the numerator, that means minus 1 by 2 plus 5 into x into dx. This is equal to, here multiplying and divided by 2, here multiplying by minus 2 and divided by minus 2. Therefore, here 16 minus x square all to the power of minus 1 by 2. Its derivative of 16 minus x square is 0 minus 2x. So, therefore, this is of the form, so f dash of x into f of x whole to the power of n. So, that integration becomes f of x whole to the power of n plus 1 by n plus 1. Here, we can use that formula, that is equal to, now, minus 25 by 4 into, this integration becomes 16 minus x square whole to the power of minus 1 by 2 plus 1, that is 1 by 2. by minus 1 by 2 plus 1, that is 1 by 2 plus 5 into x square by 2 x integration limits 0 to 4. Here I used the formula integral f dash of x into f of x whole to the power of n dx is equal to f of x whole to the power of n plus 1 by n plus 1. This is the formula. Therefore, this is equal to, here 2 ones, 2 twos. Therefore, minus 25 by 2 into upper limit 16 minus 4 square, 16 minus 16, 0, minus lower limit 16 minus 0 whole to the power of 1 by 2. 16 whole to the power of 1 by 2, that means square root of 16, that is 4, minus 4 plus 5 by 2 into upper limit 4 square, 16 minus lower limit is 0. Therefore, this is equal to 25 into 2 ones, 2 twos here, 2 ones, 2 twos, here also 2 ones, 2 eights. Therefore, this becomes minus into minus plus 25 into 2, 50 plus 5 into 8, 40. That is equal to 90. So, integral over s f bar dot n cap ds is equal to this is our required surface integration.